This session is a panel session about deploying RDM infrastructure and, of course, especially NOMAD Oasis. And we've invited here today an array of panelists. So all the people you see here now, and also one person online. I'm going to let them introduce themselves. These panelists sort of represent an array of different positions and experience with Nomad, and I hope that with that we can have a nice sort of balanced discussion, especially sort of at a higher level of what challenges and experiences they have had that hopefully then they can pass on to you. And also at the end then we'll have an open sort of Q&A and discussion session. So the format really quickly is that I'm going to let each of the panelists introduce themselves through a few slides, each just a few minutes to introduce themselves and their NOMAD Oasis and Institute and such. And then we're going to have a panel discussion where I ask questions and then we go around and answer. I think for the panelists, I think I'll just ask who's ready to answer. We'll start like that, and then we'll see how that goes, but we can remain flexible in that way. And I will also sort of time us a little bit so we don't get too stuck on one area. So maybe I'll interrupt you if you talk forever, but we want to, let's see how it goes. Let's develop together the idea, and then at the end, again, a Q&A. So with that, let's get started, and you can just stand and as we go through your slides, we have them here, and when you're ready for the next slide, just go ahead and say that. And please use the microphone because we're recording.
Hello. So I'm Edgar Nandayapa, and this is my colleague Dimitra. We are working at the Humboldt-Universität Berlin, and we are data stewards for a few institutes within the Humboldt-Universität Berlin world, especially in HighSprint and CSMB. So this is CSMB and HighSprint is over there in a different building. We have a little bit of an overlap with PPComB, and this is why I also added it, even though there is a specific data steward for the overall tasks of PPComB. By now, we have loaded more than, probably by now, 6,000 samples. We have 38 active users and 7 different research groups that are actively using our apps. I didn't mention it, but we do research and development for solar cells and solar photovoltaic devices. We can switch. So we are trying to get our Oasis in a level where users can come and directly use it. So we are also in the status of convincing people to use our tool. And infrastructure, it's a machine, a virtual machine with these specifications. Users and scope. Most of our users use the data base to upload their data, to visualize and analyze the results. The main motivation of the adoption is to have a single place where all the experiments can be uploaded, and this opens a lot of doors for collaboration, for broader analysis, for sharing the information, and some of the advantages for users that you can they can access it remotely, and we have customized data analysis tools. In the long term, we want the whole institute to use Nomad as a management tool and also for analysis. And we have several projects in the pipeline to automatize the acquisition and upload of data, and then the processing of data to make the analysis much easier afterwards. I think one of the more interesting goals is to align the terms and the workflows on different institutes because we have noticed that other institutes are just copy-pasting our setup for the Oasis. So we have an opportunity to set some standards, which is great. So we want to do this correctly, and this is like the most overarching vision term.
And if I may add, along this lines also, because my project involves a European-wide consortium, so we are talking about 18 partners. We, as HCB, are the data stewards responsible for running and maintaining this Oasis, bringing together these partners, the message across of how do we unify these terms and involving new people in the whole NOMAD infrastructure. So it's not only the internal job that we do, but every time that a project gets written, Eva, Unger, which we represent, makes sure that a position is asked for the whole data infrastructure, so that it is not a sudden ad hoc result, oh, we need somebody for the data, but it's ingrained already in the project description. Thank you.
Okay, thank you very much. Next is Martin.
Hi, everyone. Try not to step out of the view. So I start at the bottom of the slide now. I'm a postdoc that did my PhD in 2025 in the group of Claudia Draxel. This is a solid state theory group, as you can see on top of the slide again. Here at HU, actually, it's just behind your backs in the second floor. And we are the co-developers of the exciting team here, of the exciting density functional theory code. Here, the logo moved a bit on top of the text. And in our group, we have about 40 people, including all the students. So it's a rather large theory group with a lot of development. In the domain, so what we do, it's a density functional theory code, as I said, but it has a strong focus on theoretical spectroscopy and post-DFT methods that are, just for everyone who is not familiar with the electronic structure theory, is a very resource-intensive subject. So we run our code on high-performance compute systems that are provided, for example, by the German high-performance infrastructure, the NHR, and we submit the jobs there, we run them there. They might run for up to several weeks, and then collect the results. And these are the results that we use to do our research. So in the group, it's not only running the code, it's also development of new theory and codes, and the actual code, which is the Fortran code. We do high throughput calculations, we compute benchmark sets, and we also do machine learning with the data that we compute. So in terms of the setup, we have a production deployment since 2023, and these are running on virtual machines in the HU cloud. So this is like a cloud infrastructure provided by the Humboldt-Universität. And this is running on one single machine with 8 cores, 64 gigabytes of memory, which is necessary for doing all the parsing. And we do have twice 25 terabytes of hard drive, a virtual hard drive, where one of them is for backups in case the administrator, that is me, deletes something that should not be deleted. Important is that our Oasis is open to the public internet, which is necessary if you have the high performance compute centers. They need to have access, so we can upload straight from these machines. And we have a whitelisted access for all of our members. We have about 10 active users, which do mostly high throughput workflows and produce machine learning datasets and benchmarks. So the main motivation was data sharing and backup from these systems, because all these data needs to go somewhere. Long term, we want mostly to have to upload everything automatically after we run it. We want to use all the machine learning training and prediction, and also analysis and visualization to analyze all results on the fly. That's it.
Good. Thank you.
So I'm Mark Trevor. I'm representing the big chemistry course consortium, and I'm the data scientist. You can So in terms of the consortium, we're a national growth fund project from the Netherlands that's funded until 2030. We've got 97 million euros, which means at the moment we've got about 100 members, so 50 PhDs and postdocs, 25 PIs, plus about 20 to 30 bachelor's students and master's students passing through the consortium, working on related projects each year between these 5 institutions. So Technical University Eindhoven, AMOLF, which is a research institute, Radboud University, Universiteit Groningen, and also Fontis, which is the University of Applied Sciences. So the idea behind the consortium is we are developing the tools for the next generation of the chemical industry, particularly focused on the Netherlands, but more widely in Europe. And the idea is we're going to be using AI and self-driving labs to accelerate the development of the next generation of formulations in industry. So the 3 big research topics are films, foams, emulsions, peptides, proteins, glycosates, and then catalysis and chirality. So in terms of our vision, we are currently in the pilot stage of deploying NOMAD, in the sense of we've got production instances running, but we haven't onboarded any users yet. So full production is aimed to be the next quarter of this year. We're looking at supporting both the academic consortium and also future commercial operations. Because we're funded by the National Growth Fund rather than the Dutch Research Council, we have to be self-sustaining post-2030. So that means we have to valorize our research and have an impact monetarily in the Dutch economy. So NOMAD Oasis is designed to provide a research data management platform where we have control. And the idea is we can do scaling of this, both horizontally, so this means more NOMAD Oasis instances, but also vertically, so this means larger instances which have more data and more compute if lots of people are using it. Long-term data access management and also the cybersecurity of all this data is critical for big chemistry's operations moving forward. So this is our current vision, where we will have users in all the research labs generating data, and initially stored locally, but then we'll be collating that to deposit in an Oasis for that research institute. And they'll also be recording their experiments using electronic lab notebooks. So here we're also looking at using ELO, FTW, and Commotion in the consortium. So we've got an integration issue there to resolve. And then we'll be depositing data within an Oasis. So this would be for Radboud, or Fontis, or Technical University Eindhoven, or Groningen, or AMOLF. And then we'll want to collate all that data together into a central big chemistry Oasis. And since we have to think into the future and being able to valorize the data we're gathering, we also want to be able to host other Oases for specific companies. So this means the security and controlling data access is quite a large and important part of the work I'm doing sort of centrally for big chemistry, and thinking of how do we manage these ideological differences between commercial exploitation and open academic science. So just know I've got a talk tomorrow morning where I'll be going into a lot more detail, including on the technical side. So that's everything.
Yeah. Great, thank you. And next is Lorenza online. You can.
Okay, it's my turn.
Yes, please go ahead.
Okay, so my name is Lorenza Ferrario, and I'm a researcher at the Fondazione Bruno Kessler in Italy. And today I represent the project infrastructure that is called the iEntrance. It is a project funded by the Italian research government in the resilience plan, and it is aimed to build a distributed infrastructure coordinated by the National Research Council, the CNR. And the main topic, the scientific domain is that of nanotechnologies. And more specifically, the project wants to develop nanomaterials useful for the renewable energy domain. My role is supporting the work package which is arriving to develop the fair data management, because the infrastructure is not just hardware, but want to develop a well working digital infrastructure for future use of the infrastructure itself. As you see, this infrastructure invested a lot in new instruments, laboratory instruments. Many of them are for characterization, but we have also many tools dedicated to material synthesis. And so we have all the partners, which are 13 research institutions inside the CNR and the Italian universities, which decided to define this shared project where each unit has a specific role. So the point was how to coordinate this distributed infrastructure, which is present in several Italian regions, and to define also how to scale, let's say, the management of data from the single laboratory to the infrastructure. And for this, we dedicated the whole work package to train the researcher to this aim and to build the infrastructure. So focus on the materials, but also on the development of the fair-oriented digital infrastructure. Next, please. In this context, we now arrive to a pilot state of this infrastructure. So we have a NOMAD Oasis server already installed, which serves all the project, and we have more than 100 researchers which are starting to use this platform. The user are, as I anticipated, researchers in the field of synthesis and characterization of nanomaterials. And the main motivation of this work was to find a way to manage all the raw data coming from the experiment developed by this user in a form which allow exchanging information among all these researchers, and also outside the infrastructure. The motivation was exactly this, to find a way to decide how to represent this data. There are data that are related to instrument, but also to measurement, and also to material, and to fabrication, characterization, and what is really important is also to define a common view of this information, to make them really useful and usable and searchable inside the community of the reference community. Okay. So this brought to the long-term vision, that is now to pilot this experiment, but then to keep and further improve this installation and this NOMAD Oasis infrastructure, to keep the infrastructure, iEntrance infrastructure, alive and working for the community in the last 10 years. This is also because this infrastructure is connected to a project which is finishing in the next weeks, but must guarantee the access to external user for the next 10 years. So you can imagine that from this point of view, offering to the external user the know-how developed by the infrastructure means also to give to this information and data a comprehensible representation and also the possibility to really make this data machine actionable for future use. And last but not least about this, because external users could be both research institutions and companies, we are also trying to take advantage of all, let's say, the possibility offered by the NOMAD platform to be able to guarantee, for example, the IT management for industrial connected activities and to share openly what is not protected or does not require any protection agreement. Next slide, please. So, FAIR as a structural asset, the NOMAD Oasis platform allow to work on this different level. So the internal coherence, so to find a common language for all the units and all the laboratories, give an external value, so be able to open in a comprehensible way all this information and know-how to the external community, and also to be ready for the AI perspective, which in future could also improve the way all this knowledge could be used for the scientific community. Okay, I think it's all from my side. Thanks.
Thank you. Oliver?
I will get my slides from here.
Yeah.
All right. Yeah, I'm representing the Paul Rude Institute for Festival Electronic. That's solid state electronics in English. We're an institute of the Leibniz Association with around about 100 people working there. We're located in Berlin, not in Adlershof, but in the center of the city. And we are basically doing basic or fundamental and applied research at the nexus of solid state physics or condensed matter physics, materials science, and device engineering. What else did I write? Oh yeah, most importantly, we're a center of competence for molecular beam epitaxy. That's a very interesting technique to grow thin functional layers. And at the bottom, you see a kind of panoramic view of one of our two RDM labs. Basically, a lot of stainless steel, lots of exciting growth experiments to be done. What my person, I'm leading the activity on functional oxides in our institute, so on oxide materials. I love MBE growth and understanding details of it, and yeah, I'm happy to be a co-PI of FAIRmat 2, and I wished we had a data steward, because I'm not a data steward, but we desperately need one or two. Right, so at the moment I'm kind of trying to push digitization as a side business together with a few colleagues. Anna Tim is here, who's coordinating the effort at our institute. And we're happy to have hired a student assistant who's doing Python programming. All right, let's move on to the next slide. Current status, yeah, with that manpower and bandwidth, we are not that far. So we're basically at a pilot phase where we are, say, mapping the workflow for the architectural growth, including substrate preparation and so on, but also the growth process, in situ characterization, little ex situ characterization onto the NOMAD Oasis. I'm more or less convinced or forced my team members to feed data into the Oasis. So we are basically, including myself, 4 users at the moment. And yeah, the main motivation is for me, first of all, to have well-organized and automated research data handling. So we have to having like handwritten lab notebooks and files here, there, different formats. And when a PhD student is gone, you cannot make sense of the data anymore. At least it takes a lot of effort to search data. Also, for grant writing, we need to convince the granting body that we are FAIR compliant with our data. And in the end, we would also like to publish our research data, at least in conjunction with research papers we are writing. And currently, NOMAD is a good way to do this. My long-term vision is basically to have a professional research data management for the entire institute. And there are one or two thoughts that I picked up. Right. Data servers. We're having basically 3 NOMAD Oasis installed. One is a production instance. The other one is like for testing new versions of NOMAD, and another one for development. They are all behind the firewall, so they are not accessible from outside unless you have a VPN connection to PDI. And regarding projects, when I was writing EU projects, I was also putting like in that PDI will host an Oasis for the entire project, like for all collaborators. And this year I also started putting in a position for some person to do the actual work because it takes a lot of work. Okay, thanks.
Perfect. Thank you. And last but not least,
my name is Christoph Koch. I'm from this Humboldt-Universität and also member of this CSMB here. And we run a number of electron microscopes. If you stay at this first slide for now, you can see electron microscopes. They all have the same name, electron microscope, but the data they generate is very diverse, right? You have multidimensional 4, 5, 3, 1-dimensional data. They can be spectral, diffraction patterns, images, and so on. And this is already a challenge also for research data management because you want to have all this data represented in a nice manner. If you move on to the next slide. Right, so here you can see that's the CSMB that you're in right now, and next to it is the Department of Physics. And if you move on one more, you can see the number of microscopes installed in these buildings. And they're not all from Humboldt-Universität, but they are from neighboring institutes. For example, we have the Institute for Crystal Growth, we have the Helmholtz Center that you've heard before. There is the Max Planck Institute, the Ferrario Institute. So a number of institutes have put the microscopes here, which actually is an interesting challenge. Of course, it's a very nice environment. You have now many microscopes and very diverse and complementary techniques, but the challenge is how do you really create now a common data space for them? And I maybe should add, we run in NOMAD Oasis. I don't have a separate size for our configuration, but since many people have mentioned this, we've just upgraded it. It has about 500 terabytes of data space with space to increase to more than a petabyte. We just add more disks into it, so it has a lot of empty slots still that we can fill. That means we have enough for at least a few years. But you know, these fast detectors nowadays, they can generate several gigabytes per second already. So you can really fill this space up very quickly if you don't compress data. So data compression actually in the research data management, at least for these techniques, is a very important issue. Then we also combine it with online data processing. So the same server, the same rack that the storage is in also hosts like 8 GPUs, one of which is an H100 with 96 gigabytes. So we do also online data processing, which we think is very important. And if you now move on to the next slide, right, I just wrote down a few challenges that I think are not so easy to address, or at least that we're working on, that I'm working on. For example, even if you are basically the head of a group, you still want people to voluntarily and excitedly work with the NOMAD Oasis and with all your research data management ideas, and that is not always everyone's priority. So really motivating them. And of course, there are some ideas that and some of the stories that you can always bring and say, oh, this is really important because, for example, there was a student who had to write a report on his project, and he had already moved to a new project, or a new employer. And then a year later, it was very difficult to actually retrieve all the data and so on. So you can bring all these stories, but to really motivate people to actually buy into this is not so easy. And how do you, also standardize how people really fill in the description of the experiment, which is not always basically, there are not always tags for in your fields. And EM specific, right, as I said already, very diverse data, so very different techniques and also very large data sets, tens or sometimes even more than 100 or 200 gigabytes in a single data set. And then, of course, this connection with online data processing and so on. That's hardware related, but yeah, so much for that.
Great, thank you. Thank you to all the panelists. Let me just stop this. Perfect. Great. Then I think, I mean, that was, for me, that was a really nice introduction. And also I can see that many of the questions that I have prepared in some ways were hit by different people. So this is, I think this is perfect because now we can sort of go into either a little bit more details or hammer the the important points. So I've organized the questions into a bit like different categories, starting from sort of motivation. So starting from the beginning. So think back to when you started with this endeavor, your journey with Nomad, and like your motivation or decision making, or maybe if it's not you in particular, your what you sort of think the motivation was, or what you feel the motivation is now. So I think lots of people already answered what are the key driving forces to investment in RDM infrastructure, so the question is, I mean, one specific question is why Nomad? Why did you choose Nomad over other alternative approaches? And if you considered alternatives, then which ones did you consider, and what was the evaluation there? So I changed my mind a little bit. I think I want to just I'm going to try to just go in a row. And if you want to sort of pass on the question, you can just go to the next person, not a problem. So I start with Martin.
Yeah, great question. So the motivation, in my case, in our case, is pretty straightforward. The leader of our group is actually the speaker of FAIRmat, so it coincides with what we with the original plan. But then, on the other hand, it also means that these were also the important points for us, like what Christoph mentioned. Data organization was one of the original ideas of why the idea of Nomad started in 2014. And since then, the infrastructure has changed a lot, and also the way we can interact with it has changed a lot. But the original idea is still the most valuable point also for us, and this is also what we use it the most for. I forgot the first part of the question. But,
yeah. So from the big chemistry perspective, part of the reason is we're wanting a relatively generic platform that can support the diverse data that will be generated. And we had actually, initially when I started and we're investigating different options, there was a small consideration for doing something ourselves, but then when you realize how much effort needs to go in to build something like this at scale and then get the adoption, it was much better to pick an existing platform. I think there was also a strong drive of having an open source project because we're a consortium that's predominantly academic, but for our long-term funding, we need to be able to commercialize. So it's also the motivation of being able to get the academics involved in the consortium on board, and potentially also expansion further into the Netherlands. And we're also collaborating with the Max Planck Institutes as well with projects. So we've got some cross-border collaboration already. So this is where we're wanting to not reinvent the wheel and align with other researchers within Europe. So then if we come up with standards, others will hopefully use them, or if there's standards already out there, we can use that effort and just add to it.
Can I just clarify something there? Do you think, so you said customization, like a generic platform that is like able to be customized, and then also the open source aspect. Do you think one is, in terms of, I mean, how would you sort of position Nomad in other possible solutions? Do you think it's the customizability that's the unique selling point, or the open source, or both, or how do you think about that?
I think both, because when we were thinking of a central sort of database service, we were thinking we could go the Postgres sort of SQL type database, or MongoDB, so go fundamental technology layer, the layer below Nomad. But then you kind of need to build that layer above, which Nomad sits on, for interfacing with those lower level databases. So that layer takes a lot of effort to build. So it's having some hooks there, I think, for the specific customization. I think that's what Nomad provides. It's so we don't have to know the entire stack. We can deal with something a bit more abstract, a bit less complex, a bit easier for researchers to get on board with, rather than having to know the ins and outs and intricacies of how MongoDB works and the querying there. That's, I think, a big thing. We want easy to use tools which researchers will be happy to spend a couple of days in a workshop learning, and then all their workflows just work with sort of 5 minutes tweaking. We don't want them having to spend days having to understand how to get the data in the right formats, which hopefully is something others have thought of.
Perfect.
Right, about, well, my or our own motivation, maybe a little historical. At the end of 2021, there wasn't kind of internal competition for ideas, for internal grants, for like a position on something. And at that point, a colleague of mine, Jonas, and I came up with the idea, well, we need to take care of our research data, also to comply with funding agencies in terms of fair aspect and data storage treatment. So just writing we'll keep our data for 10 years on a backed up server is not enough anymore. At that point, we proposed something on data management, and we knew about FAIRmat, and they're all colleagues where we collaborated, like Claudia also in a different project. So that was pretty clear for us that it's probably a good way to go with them, because we can get the support to work on this. The interactivity nucleated that out of this competition funding, which we won the fund, we hired a person to start taking care of data. And then we looked into different options. One was ELAB FTW, and we relatively quickly discarded it based on, I think, 2 points. One point is there's just, as far as I know, a single programmer responsible for that, and if that programmer I don't know, gets run over by a bus or decides to do something else, the product is not supported anymore. And the other one seemed to be less well structured than that.
Okay, so that's actually a very good starting point for me, because a number of years ago we already looked into electronic lab notebooks, and of course also a way to document our data. And I ended up actually looking through all the different ELN and data management solutions, and I decided for the FTW, which I then tried to actually encourage everybody in the group to use, but it has a number of downsides, which I won't get into now, but then ended up becoming part of the NOMAD team, and that really changed things, because then we were able to really have all the ideas that we now developed in the meantime for someone to work on. For example, common data formats, right, which you just mentioned. That is actually a very big effort within NOMAD. And also being able to really interact with all the data directly online. And that was already before NOMAD. We tried to implement an ELAB-FTW. I had hired somebody who's probably in the room, I don't know, but hired somebody to really work on this, and that of course went on, but I saw that it really is a big effort to really do it as much as we would need it to really be comfortable for everybody to use and convenient, and also a win in using it. Yeah. And so, yeah, with the NOMAD effort, it was really great, because we were able then to shape the project in a way that we thought was good, at least for our needs, and hopefully also other needs. And it really has a lot of the capabilities that I dreamt of when trying to work on this myself.
So I think for us, there are many motivators, but one of the most graphic ones I have for you is a few years ago, a team in my group decided to digitize all the papers that have been published on perovskite solar cells. This was a big effort of 200 scientists all around the world that read 40,000 papers or so. And this led on to the perovskite database, which you can actually find in NOMAD. I think it has something around 46 data points.
46,000. 46 data points?
46,000, sorry, yeah. And the curious thing is that you cannot really use this for anything because all the samples are different. So it's hard to get strong metadata to do any machine learning or any sort of analysis. So then my boss saw that just by paper, there's more than 13,000 substrates being used every year in our lab. So each substrate has 6 cells. So yeah, you can do the math. It's a lot of solar cells per year. And if we could harness all the metadata and information of these solar cells, maybe we can actually find something that no one else would so easily. So this is one of the biggest motivators, I think, to really try to get a bit more out of all these samples that are being produced, because what's published is only a tiny, tiny fraction of what's really produced.
And do you think like the adoption of NOMAD in particular was motivated by the momentum in your domain, or the other connections more similar to sort of Oliver and Christoph, or what do you?
I think it has not been so easy, so I don't think there has been any momentum. I think many things came together in the sense that there was this data steward, Michael Gote, that probably many of you know. And also my boss was very excited about the project, so she started joining different forces to work towards this solution. But yeah, now that we are trying to put the project out, we can see that many people are not really interested, because it's a lot more effort. Maybe it's not exactly what they need because it's missing this tiny little thing, and just because of that, they rather do their own solution. So I think, yeah, maybe it's a combination of the right people at the right time.
Okay, thanks. Please, Lorenza, the question again is driving forces for the platform, and especially especially adoption of NOMAD.
Hi. I would like to add a comment about why we also chosen to work with the NOMAD. And you mentioned a lot, of technical advantages and the flexibility that is really important. But one point that we evaluated is the long-term sustainability. Okay, because when you ask to your community, to your group, to your research group, to change the way they are working, and you force a little bit them to start to share information and so on, and to use a new tool, you also should guarantee that they don't have to restart in 2 or 3 years. So we consider that NOMAD has already a long story, and it seems also, very likely that it will last for many, many years. Not only, but it's also trying to develop with say transparent and transferable technology, so that if tomorrow I would stop working with NOMAD, but all the data that I have saved are in a format that can be transferred somewhere else. And so it's really important to evaluate when you have to define a strategy for the research data management, not just how powerful is a tool now, okay, but how long you will be able to use it without a further, say, a revolution in your institution.
Yeah, that's a really great point. Thank you. So from there, it's a good jumping off point for the next question, which is more now in the direction of resources and investment and planning. So you're talking about sustainability, Lorenza, and so I'm going to stick by Lorenza, and then we continue the round, so that way we keep switching order. And so I want to ask about the personnel that are needed. So I know, Lorenza, you particularly were your unit is has been active in like early adoption and development of the plugin. So maybe you can comment on the personnel needed in terms of like data stewards, IT staff, or the integration of scientists in this activities. Maybe you can give a little bit like sort of what is needed now in the pilot phase, and then what maybe is the long-term need of personnel for the sustainability of such a thing.
Oh yeah, for sure. At the beginning, you really need the data stewards because, at least in our experience, it was a matter of introducing a new way of working, and it's really important to really clearly explain the advantages of such a choice. Okay, how it will improve not just your working style, but how really could empower the result of your research. Okay, and this is this need at the beginning, I say, sort of more philosophical discussion, not just technical one. But then, and it's not so easy now, still now to find these skills. These professional figures. They are growing now. Okay, so it's something that I hope skills that will be further developed in the next years. Then obviously you need good programmer, IT expert, but these are, say, more consolidated skills. Something that is important is what we call the domain expert, in the sense that then you have to link these two things. Okay, from one side, who is the expert to support the development of the platform, but which should also speak with the researcher, which is probably not expert in that, but is very good in, I don't know, synthesis of nanoparticles or SEM or something else. And so also these figures that are not just IT-oriented, neither nanotechnology-oriented, but that can understand both contexts and make people to collaborate in a supportive way.
Okay, thanks. Thank you.
So the question was about the personnel that you need, right?
Yeah, you can, the personnel that's needed now or in the future, or you can also comment, I mean, Lorenza is bringing up this like interfacing layer between the sort of developers and the domain experts. So in your case, being part of the group itself and making this transition yourself, how do you, sort of what is needed there to make that transition or something in this direction?
So yeah, so I was not the first administrator of this Oasis, but we started with a student assistant, which in retrospective was not the best idea, because the student was very motivated, but he was at some point either lost interest or kind of disappeared, which left our Oasis sitting around for quite some time without anyone interacting with it really. So I think a very important consideration for this person is first that they are really interested in the topic, and then also that they want to engage with the people in your group, right? Because they can take part of the motivation for adopting these kind of technologies, adopting the data management parts. I think personally, I would think it's also good if you have if your data steward somehow has like a personal benefit from the data that you put there, like not a personal, but or in your group you have a research project that needs this data, right? Or you create this on the fly as you create the research data management plan, because then you also find all the bottlenecks and all the problems that you that the current approach maybe has. For example, that could be that the schema does not have all the information, which you only know after you try to use the data for something, right? Yeah, and I think, I mean, in theory, with the theory data, a lot of people have a lot of experience with Linux, with operating systems and all these things, because we have to compile our codes ourselves. But I think a general interest in that is also useful for the person that should do this job.
Like, keep in mind that we're talking about like different scale. I mean, Lorenza's talking about a huge scale. You're talking about a group level scale. So just as we go on.
I can talk from both scales, essentially. Because I have met data stewards across the whole of Germany, and there is two flavors. Some are isolated data stewards that were hired by a department that didn't have any strategy apart from come and implement and devise your own strategy, and those are pretty much lost cases. So one thing I would say is, at least if you're an isolated institute or a group, you already have to have a data strategy that when you invite somebody with a 2-year contract to build it, they don't have to reinvent the wheel, they will not drown, and they can already start implementing something. If it's within an institute, in HZB, pretty much we have a good experience that by now we are a good amount of data stewards that we have also a common strategy, because we are servicing nomads to a big extent, but for so many different groups that are heterogeneous, but at least we also have a common ground of the different versions of Nomad and how do we implement. What I definitely recommend, and what has been Eva on this experience, is you have to ingrain it in the project ground for a data person position. Otherwise, a scientist, as you already mentioned, within 2 years, but they are drowning to provide papers, might drop it at any time. They don't have the capacities. It is a structural issue, as is a structural issue pushing forward that data sphere or data management people contracts become permanent and are considered as permanent positions, because how are you going to build an infrastructure for long term if you also do not have this long term view? I think, and what Lorenza mentioned before, definitely the domain expert versus an IT person, especially in the first stages, a good communicator is needed. So, in my opinion, it doesn't matter if they have more of one side or the other, but the communication is key, because exactly you have to do all of this back and forth, and the expectation management and handling, that you need the feedback loop that you go implement. It's not a ready-made platform. We build it going towards the end results that everybody wants. So, too much time.
Okay, yes, yeah, go ahead.
Sorry, forgot to say, we calculated 25, one data steward per 25 scientists is the most efficient way. Exactly, yeah. If you have heterogeneous groups that you have to build so many different schemas, that's our estimation of would be a good case scenario. Thank you.
That's very useful. Thanks.
That's also very useful. So at the moment, in terms of central consortia, I'm the only person within any sort of data and IT role at the moment. We are hiring a software engineer, but this is something where at the moment the consortium is very much a clean slate, which we've been gradually building and figuring out this is what our vision was for the long-term view, but filling in what the strategy is to meet that vision, and then the actual fundamental infrastructure requirements below that as well have been a lot of my work. So that's also something we've been exploring and looking at what type of team do we need to support not just the NOMAD Oasis and getting data into it, but actually keeping the lights on in terms of making sure the infrastructure the NOMAD Oasis runs on will also still be functioning for as long as the NOMAD Oasis needs to function. So this, I think, is something, because we're in that position as an organization, there's a lot of moving parts there. So it's finding the right skill sets, I think, is something that's come up from the previous speakers. And that's something as well, is you never find the same person, one person having all the skills to manage all these different layers. I'm trying at the moment, but that is not sustainable. And that's part of the reason why we got external consultants in to help build that initial infrastructure layer that's everything will sit on top. But this is something as an organization going forward, we need to be looking at getting sort of data stewards. So it's using the existing data stewards within some of the research institutes, but they're not responsible just for our projects, but multiple others and only some parts of our wider consortium. So that's where we need to have our dedicated setup as well.
if I may comment really fast on, I mean, I think this is like, I mean, this is the goal of this this session is to share the experiences, right? And I think what you mentioned about this sort of quantitative experience, so like this is our estimate, and what you're saying, we're trying to figure out like what the resources needed for sustainable maintenance and of this infrastructure and such. This will be something that we can, like, a challenge for us in the future as a community to continue, like, develop these quantitative aspects and then share them with other people, because these are extremely useful for trying to plan ahead and actually know. Many people come in without knowing what the actual buy-in is. They think it's this much, but it's actually
But the same empirical estimation, we don't have a formula.
no, of course. Formula. Yeah. So yeah, let's continue. Oliver.
Right. I think it has been said what personal takes to good data management. Can describe the current situation in our institutes. We have IT that's taking care of the server, right? Take it off. Data steward is, I don't know, 10% of myself, and I don't know how many percent of Anne. We're very glad to have Edgar as a programmer. So he's a master student in data science, and basically with the help of him and his programming skills, and also the big help of the FAIRmat consortium like Sartak, and of Blade Data, a related company, and we are making now progress. Before it has been painstakingly slow, and now I see we have weekly meetings, and so we see some real progress, which is fun. And about the future, I believe in the future, that might be a provocative statement, and AI will take care of everything anyway, so we don't need any person anymore to look at.
Somebody must control the AI. First of all, make sure that it does the right thing, and second, catch all the errors that it makes, right? So yeah, as I tried to explain, we started out with our own solution that we wanted to modify this existing ELN to do what we want, and that was really a lot of work, and it was very slow progress. I think one thing that hasn't been mentioned really is there needs to also be somebody who constantly then also updates the NOMAD Oasis, and that already is some effort, depending on how much you have actually configured this to be specific to your own location. For example, in our case, the way that we ingest the data directly from the microscopes means that also certain permissions have to be set, and then an upgrade is always a big effort, and really needs somebody who knows what he or she is doing, and so that really, I would agree. The one data steward for 25 people, that would be nice to have. Yeah.
Yeah, I mean, I think it's not, I don't think it's really a discussion for now, but like, I think it's interesting, like, there's actually, it was mentioned, like, there's various roles that are being filled here, and the question is, like, what is the most efficient and, like, way, both time and money, to fill these roles, right? Like, do you have one person who's covering this very broad skill set, right? Or there's mentioned now, like service companies or data stewards or people inside your group. This is depending on the scale and what you're trying to, and the sort of the robustness that you need. And so this is also something like to continue thinking about, I think. But I want to move now to so away from the personnel maintaining and more like in your slides, it was already mentioned about adoption. Like, this is, I think we all know this is an extremely difficult problem. So the technology and the setting everything up and customizing is one thing, but how do you actually get people to use the system and be excited about it and see that it can be like actually a boosting, like have a boosting functionality for the science. So the question is, how do you encourage adoption, and maybe, or what resistance or barriers have you experienced, and what incentives have proved efficient for you? And I'll start with Hotzebein from Ant.
So it has been a complicated task. So like, I think you have either the carrot or the stick approach, and I think a combination of both is good. So we started with a pure carrot strategy, and this means that we started building a lot of apps for analysis of all the measurements we have. So a JV analyzer, for example, like a specific type of measurement for solar cells, in which you can see the measurement curve, but also you can get all the values that are extracted from this curve, and you can plot them in a box plot, for example, and you can compare all the factors that you changed during the experimentation. And instead of a scientist taking 2 hours to do this, now it's just a click. So yeah, we spent a lot of time building this type of apps. We made some help desks every week, so people can come and ask if they have any issues. But this is really not enough, in the sense that there's 1 or 2 people who are really motivated and interested, and they want to help the tool to grow and do what they want. Because also since it was not many people, we would be developing all these apps to their needs, which I think for them it was great. But it's also important to have the PIs, the bosses, telling people, okay, you need to upload your data. Because otherwise, all the people who are a bit reluctant because of X reason, they would just not do it. No? So if the PIs and the groups, as a society, as a group, start pushing for the usage of NOMAD, I think the growth would be much faster and better. I think at the same time it's good to have all these customized options or solutions, so that the work of scientists is faster, because this is the whole point of having a nice research data management tool. But yeah, it's important to have the top-bottom approach.
You want to mention the experiment, Nandayapa? One of the potential solutions, for example, that was thought is that users would submit their experimental planning, and after this gets approved by the supervisor, then they would get access to the chemicals, to ordering, so that this could mandate and also end up in cost cutting, because you remove duplicate experiments. Or, for example, a group leader could mandate by checking weekly the uploads by the users, having a sort of report. But if there is no institutional mandate, nothing will happen. Then you have the users who are happy to use it, and they see the benefit, but you don't get all of the basis.
Okay, thanks. I'm going to move to Lorenza, and then we'll go this way. Lorenza?
So it's about motivation. So probably the hard part of the work, in my experience, but I see that researchers are really sensible to the possibility, okay, that their work is appreciated, let's say. So the tradition is to publish, but when we want to share not just say your paper, but also data, then they understand that working on a platform like NOMAD is very useful. So one of the way to try to motivate them is to make them realize that if they want to share their work, okay, they should start to apply to this type of say common tools, and this is also from the formal point of view useful, because you can say, okay, this is recognized data repository, so you don't have to look for other solution. And the other is also internal, as you mentioned. Our experience is about this distributed infrastructure. So the point were not just the single researcher, but how they can collaborate with all the others in the project, and so the possibility to easily, let's say, share key information, not everything, but with colleagues. Okay, also was convincing them a little bit. But yeah, we're still working on that.
Great, thank you. Martin.
Yeah. Okay. Again, I have a bit of a unique situation because of the of our management, of our boss. However, I would like to say that the adoption in the last years was slowly increasing. So in the beginning, we really had to we needed to be motivated a lot from our boss, but eventually now, especially also that the whole topic is growing and that also FAIRmat as a project is growing, many group members are interested themselves to learn about this. I think potentially because they see it as a career step that needs to be done, and I think this may help in general with progressing the whole with the whole topic. And then I think it's yeah, in terms of motivation, it's always a problem if this something that happened to us before is people try it out and something does not work in the first try, and this is a very crucial moment. So if this happens, then you need to invest a lot in order to convince them to pick it up again. So I think that it's worth investing a lot into the first contact with the tool, I would say. Yeah, so I think in our case it was also because we started very early on with some development versions that were not as advanced as what we have now. Yeah, and I think basically what also the other said, giving people a way of using this data that they upload and a way of participating in the process will certainly help.
I just hope a little bit at that, just saying that, I mean, just to both point out what a huge difficulty it is in your slide. You said there you have 10 regular users out of 40, so even with this pressure from above, like it's non-trivial. And
I mean, you cannot micro-control your people, and you should also not, right?
But then it's key, like these other factors that you say about things work and that there's good onboarding tools and things like this. This is like really essential to getting people on board, because you can't force them. Like it has to be easy and it has to work.
Absolutely.
Right.
I think for us, we're moving towards that first contact stage. So this is where we're at that critical point where we've got the NOMAD Oasis running and functioning that should be stable enough that when we start introducing them to researchers, we hopefully survive first contacts, which is, I think, the sort of key stage we're at now. And this, I think, moving forward is going to be quite important for our success as an organization, because since we want to make our research sort of commercially successful, a key part of that is the data we're gathering. So this is going to be funding future PhD students, future postdocs within the research institutes. So this is a very long-term goal for the consortium. So there should be sort of PI buy-in, but it's also looking at what incentives we have for the junior researchers in terms of how are they going to be able to use their research going forward. I think that's something we're looking at, how we balance that.
Okay, how to motivate people to use NOMAD? I think out of the 4 people I'm talking about, there are 2 enthusiasts, so they cope with NOMAD with all its difficulties, number of clicks and problems. And then there are the critics, and they are the tough one to convince. And okay, one way, as mentioned, is the top-down approach. So that's something in the end one would need, right? We need a strategy and a policy that's telling people that's the requirement. We need certain, level of confidence or data, reliability, storage, persistence. And the benefit thing is, I think the way we can get the critics is to show them benefits and to show how user-friendly the research data management with NOMAD is, or make it that user-friendly that it reduces their number of clicks, it relieves them from tedious work and repetitive tasks. So I believe that's that's the carrot way to go.
Yeah, I would agree. I mean, it has to be, as you said, a combination of the carrot and the stick, or whatever you want to call it. So what we've done, for example, is well, I mentioned already there's the stories of a PhD student who then later had to write a report, and if you would have just done that, and please don't make the same mistake, for example. But also, yeah, providing online data processing opportunities that, for example, you have much bigger computers to process your data, which you won't get through your desktop. And also maybe requiring for all publications the accompanying data to be published not on Zenodo, but actually on NOMAD, which at some point that has to make everybody familiar with uploading data sets, generating UI, and documenting properly, and ultimately finding out that it's not so difficult, because as some people said already, it's always the first contact that you make with it. But if you have to work your way towards a final solution that you can publish your paper, you will be prepared to do it again, and that's different.
Great, thank you. Okay, a couple more questions, and then I want to make sure there's enough time for the audience to have questions and also share their own experiences. So, two more questions. First one is let's move to a more positive subject. So think about use cases or your experience in general. What's a very positive experience with Nomad? An example of a use case that really delivered quickly, or that you're very proud of, or that the scientists are happy with, or something in this direction. And we start with Christoph this time.
A good example of
a good use case example, or a development that you are excited about or were excited about when you developed it.
Yeah. Well, so for example, one thing that we're doing currently is trying to really populate NOMAD with datasets from our field. And there are plenty of datasets in the community already, in Zenodo and other areas where people upload data. It's always difficult to then really make sense of the data, because there's just the data, but hardly any metadata, hardly any description. Maybe there's a DOI, and in many cases, when people publish their data sets, there is a DOI to a paper. And so what we've recently done is just now look at these DOIs, download all the papers that go with it, and actually use LLM technology to extract and make a summary and ask for certain information basically from that publication, and now accompany the data with a human readable description that actually adds this, and that really makes the data much more readable. And immediately, there's also an incentive for other people to upload the data as well, because if there's already a critical mass that you see, okay, there are already 20 data sets on strength and title data, or whatever you're working on, then it's much more fun to actually add your own data to it, and also describe it in the same manner as people have already done, because then you can refer to it and it actually makes sense in the context of its fears.
Yeah, so NOMAD is a very logically made app or tool. And I think for data scientists, this is very well defined and clear, and you know what to do, and everything is where you expect it to be. But in our experience for lab scientists, it's not very easy to use. It's actually quite confusing. So for some time we had data stewards giving these help desks to specifically help the scientists to put their data on NOMAD. And this would take 1 hour more, it was a lot of work. Some people got the gist, and they I think they can still do it like that, because you have more control, more customization. But yeah, one of the biggest wins we had was when we removed the graphical interface of NOMAD and just made an Excel file, which sounds like a downgrade, but this is what scientists use normally for their day-to-day work. So when we introduced the Excel file, now then we started seeing a lot more uploads and people having less complaints. So yeah, this was a great win. It's not the best solution, but it's going towards the right path.
Can you explain what you mean by an Excel file? Like embedded in Nomad, or someone
No.
uploads it at the end? Anyway.
So we created an Excel creator. Each person has a very particular way of creating solar cells. Sometimes you add the layers from a solution, sometimes you evaporate it. So since everyone has a very particular process, we created this Excel creator in which you can select your processes, and it just creates an Excel file with dozens of columns, maybe even hundreds if you have many layers. But yeah, now for each column you have the different parameters that you need for the production of solar cells, and each row it's a different sample. So
But how does it get into the database?
so yeah, you finish the Excel file, you drag and drop onto Nomad, and Nomad has a parser where it knows how to read the Excel file.
So you're saying an Excel file in place of the ELN, in place of the media file.
Yeah.
Okay. Got it. Sorry, I wasn't patient. Yes.
Can I add a question? So would it then be ideal to have an inline Excel editor for that?
Yes, we are working on different solutions. One idea is to remove the Excel file completely, and then when you want to upload a new experiment, you can use an older data set, either from you or from one of your colleagues. So then you just add the variations of what you did for that experiment in particular. We are working on it because it's non-trivial, but for now we have the Excel file.
If I may jump in right at this point, because that's what I hear from my people. It's for them tedious to fill in a new NOMAD entry, and they would love to base a NOMAD entry on a previous one and then just enter the difference.
Yeah, so maybe for context, we are heavily using the Jupyter notebook, especially with an extension called Voila, which lets you do graphical interfaces within a Jupyter notebook. So it's not the prettiest solution. We are actually trying to move on to something a bit more professional, but for now, I think that Voilas cover the usage that we need, and yes, this type of functionality is coming.
Yeah, I think it's a very interesting discussion. I think it's a little bit going too like specific into one area, but there's different way. I mean, of course, like the ELN is one functionality, but actually the base functionality of Nomad is about parsing files. So you're just going back to the sort of base functionality. But I think it's interesting to continue also after in this user's exploring discussion. So I move to Lorenza, and again, the direction is a positive experience or use case with Nomad in your experience so far?
Well, the good thing is, how flexible it is, and so the possibility to adapt to a very large number of experiments and tools. So this was really a good thing. Technically speaking, okay, I don't have particular notes. Of course, it's not an easy tool at the beginning. So probably what is more difficult also for the use, for a good use, it to understand very well what are what is the architecture underlying the interface that you see, all these concept like entry, upload, and so that sometimes confuse about loading correctly what you need. But I think it's from our case, it's a matter of experience, not really of lakes that we or problems, technical problems that we had. Maybe in the future, when we will be more expert, we will also find more problems. I don't know.
Yeah, I mean, you're also in the a little bit more in the beginning phase, so it's a little bit difficult, I guess, to say specifically use cases and such. But you mean, I guess the adaptability is already seeming like promising, I guess. Okay, Martin, please.
Yeah. spectacular use cases. I have one that we have a project where we want to study certain compositions of perovskite structures, and we decided to go with a high throughput workflow. And for this, we added, so already before we did a little customization to our Oasis to be able to host the workflow traces also in the same infrastructure. So it's not a part of NOMAD, but it's living next to NOMAD. Basically, it makes it easier to do the administration for all these things. And now the success was that with this workflow, and having an Oasis where we can, the number of unpublished uploads is unlimited, basically unlimited. We could run this workflow on an HPC system. Everything was run there and automatically upload. So we basically, after writing the workflow and having someone to check the actual convergence of the calculations and like the technical part for the computation, this is very low maintenance after all. So this is a good starting point for later studies in the same way. And the Oasis is helping really much to organize all these. In this case, it's 10,000 something calculations, which is way too much to look at by hand.
Great, thank you.
Small bit from our side, because we're just starting, and I think the big bit has been working with the NOMAD team and the SLTN, the contractor we've been working with, the deployment of the Helm chart on AWS and getting that working so we can deploy multiple instances. I think it's also something one of the cybersecurity research groups in Fontis has used for testing the sort of monitoring system. So this is also something I'll mention briefly, but we're also interested in how we secure our infrastructure going forward and what the monitoring requirements are there. So I think that's something for everyone that's a chemist here, including myself, something we haven't really thought of before, but it's something with my current role in big chemistry is becoming much more important, is how do we secure our data and make sure people can't maliciously attack the infrastructure we're using.
Perfect.
Yeah, success story. First of all, that the entire workflow for the growth of our samples, including substrate preparation, is now captured in one database. So it's really great to look back at some sample and see exactly what steps have been followed, like starting from buying substrates to having a finished sample. So that's already pretty rewarding. Next one is a kind of semi-automatic tool that helps us upload measurement data, which makes life much easier for the user. They start to like it. They just enter a user ID, something ID, take the data, and it gets automatically pushed to NOMAD and associated to the related samples there. And last but not least, for the critic among the group, he vibe coded his own graphical user interface for metadata. He loves it, and basically, if we get that data into NOMAD, then there will be another success story.
Great, thanks. I mean, one interesting thought that it's not a question, but just a thought about all this is now when you're saying all these solutions, like how do we communicate this to the community? Because everyone's finding their own solutions. You have something, and this is like really, even within FAIRmat, it's very difficult, even our core development and to document and share, right? Yeah, you can. Do you want to answer?
I have another success story. So that
okay, good.
yeah, because at least with the instruments that we use, there's always this one instrument that collects all the data. Typically, there's a PC associated with it. So all the data that's been collected for the past 10 years is stored on that one PC. And now that we have this common data format, this Nexus application definition, and a converter that converts a number of different formats to it, we can now convert all to the same data format from different machines and upload all this data from the last 10 years or so. And that's quite rewarding because all of a sudden there are now 1,000 data sets or more just from our own lab already online within the NOMAD Oasis, which really helps a lot. And then really, as I said before, with the data that sits downloaded from literature, really provides already a critical mass that you are more easy to upload your data to, because you see that it's something that is growing already.
Great, thank you. Okay, last question, and maybe a slightly quicker round. What's one thing you learned, one lesson you think you want to share with the people here, the people who will watch this later about using Nomad? We can go maybe in any order. Just raise your hand, since maybe you need a second to think about it.
I don't need a millisecond. It takes a person with solid programming skills to get into this.
Okay, good. Yeah.
I would say that it's a lot of people management and expectation management.
I think for us it was getting it up to sort of production standard took a lot more effort than we initially thought it would. But I'm hoping now that the effort we've put in makes it easier going forward for others. So I think that's something where you need the right people with the right skills for the underlying IT.
Say Nomad is a great tool to share data with also external groups, because you can then invite them as users and share the data more easily.
Lorenza, anything from your side?
Well, just a quick advice, just think well, design well in advance what you want to then to implement. Okay, so think what you want this data will be used for. Okay, and so not just load and load and load, but start to from planning correctly. Okay, the aim of your uploading. Okay.
And Martin, anything?
I think everything
That's a great ending, actually.
everything was mentioned already.
Okay, perfect.